Hey, I'm Donny Crash, and I do a hell of a lot of sim racing, in particular a lot of rallycross. Unfortunately, I live in a third world country, so buying sim gear is extremely expensive. I end up paying 2 to 3 times the price purely because of shipping. So I came up with a beast, a super solid sim sequential shifter that you yourself can build at home. I had a few restrictions when I was designing this. I wanted it to be super easy to build, I wanted the parts to be readily available, and I wanted you to be able to complete it in a day. In order to achieve these goals, I decided to go with water jet cutting. It provides the cleanest result, and you should be able to find a water jet cutter near you that won't cost you an arm and a leg. I've also included a list of all the parts that you need down below in the description. If you enjoyed this video, go ahead and hit the subscribe button. Who knows what we'll be building in the future. With your parts being water jet cut, you'll notice that quite a few of the corners are slightly rounded. This may be problematic when trying to fit the other parts to it. I highly recommend test fitting everything before the assembly just to make sure the parts fit in their designated slots. If you run into a problem where your parts don't fit, here I use a needle file to file the corners square until the part does fit. This may be quite tedious, but the part should fit relatively easy once the corners have been filed out. Before we get started in the spring assembly, there's one important note. Make sure to file down your backends giving them a slight angle. This will make it much easier for them to slot into the blocker when we're busy downshifting. To start the spring assembly, we take the push rod and slide on the blocker with the skinny slot. Next comes the spring, and then finally we take the blocker with the square slot and slide that on. Next we'll take the two back ends and position them with the angles facing outward. This should slot easily into the blocker. With the holes aligned, we'll take a 3mm bolt and drive it through. I found that doing it one side at a time makes it much easier. This way, with the bolt peeking out the other side, you can simply slot on the second back end and continue driving the bolt. Inserting the second bolt is much easier as we already have both back ends tight in place. With both bolts all the way through, you can cut the remaining parts off with a hacksaw. We'll be using our needle file again to file these flush so that the remainder of the assembly slides past them. Next up, we'll take the two internal struts and slot them over the spring assembly. The big one goes on the end with the back ends, and the skinny one goes on the other side. This is a good time to check that the big one slides easily past the bolts that we've just put in. With the spring assembly done, you can now go ahead and slot into the base plate. You'll note that all parts in this design only have one way to fit in. With the handle, we're going to take one side of the handle and a piece of wood that's 22mm thick. Note that we only have to fit the first 3 holes onto the piece of wood, as the bottom is reserved for the push rod. With the handle in place, we can now go ahead and outline it. Make sure to outline any holes that we're going to be cutting. This includes the inner circles as well as the mounting holes. Once that's done, we can round the bottom just to make it neater. Cut the template out with a jigsaw. I left a little bit of material around the edges as not to leave any gaps. After that, I filed away that material using a rasp. Here you can see the rough shape. This will be sanded before assembly. I used the 6mm rod to connect the 3 parts of the handle and epoxy to keep together. Before we get started wiring up the switches, we're going to connect these using a 4mm bolt. The holes in the micro switches are at 2.5mm, so we're going to need to drill these out. In an ideal world, you shouldn't be drilling like this. You'll probably end up with holes in your fingers like I have. With the hole drilled, you can now test fit the 4mm bolt. It should slide through pretty easily. Here I take 2 pieces of black wire wound together and insert them in the pin marked C. I'll go ahead and solder that up. With the black wires attached, we'll go ahead and connect the blue wire to the NC pin. Before moving on to the next switch, make sure to heat shrink everything that's exposed. Next, we'll take the shorter of the black wires and connect it to the corresponding C on the second switch. We'll also go ahead and connect a purple wire to the NC pin. With the switches wired up, we can now test fit. We take a 4mm nut and a 4mm bolt and slot them through the top and bottom side rails. With those in place, we now take the switches and fold them back to back and slide them over the 4mm bolts. The main purpose of this is to check that the wires are long enough to reach the front of the shifter. And now that they are, we can go ahead and start wiring up the board. We take the blue wire and attach it to A0, the purple wire attach it to A1, and the black wire goes to ground. With everything wired up, we take the front plate and the board holder and attach the board to the board holder with a piece of double-sided tape. The USB port of the board should align perfectly with a slot in the front plate, allowing you to plug in and plug out your USB cable. Next, we'll go ahead and slot in the front plate assembly and attach our switches to the bolts. Before fully tightening the bolts down, make sure that the switches are in the center of the 2 blockers. From there, you can go ahead and tighten them down. With our electronics in place, we can now go ahead and attach our standoffs with our M3 bolts. These go into the 4 3mm holes on the base plate. We can now insert the bottom plate, the back plate, as well as the top plate. we'll go ahead and attach the top plate. Before bolting everything down, now would be a good time to disassemble the shifter and paint it if you'd like to change the color, otherwise you can sand it and paint it with a clear lacquer. Lastly, we'll go ahead and attach the handle as well as the push rod. To do this, we use two 6mm rods with 2mm holes drilled at either end. To find the correct spacing for the pin, insert the rod into the handle and mark off drilling points as close to the handle as possible. Included in the design were a cutout for poly bushes. These will be useful for spacing the handle within the shifter. We'll insert the long pin, 2 poly bushes, the handle, 2 poly bushes, and then the pin will be pushed through. I recommend only inserting the pin as deep as needed. This way the other parts will be easy to attach. Next, we'll line up the bottom hole with a push rod and insert the shorter pin. With the pin secure in place, your shifter should now be working. The last step to avoid any movement is to take a paperclip, insert it through the 2mm holes on either side of the pin, bend it around and cut it to size. And there you have it, the shifter ready to go. I've included documentation on how to flash your board and get the shifter working with your USB. It's extremely simple. Other than that, have fun.
Perfect.